work out what the uncertainty is in a model. Now, if your model is a simple mathematical model like the SIR model for infections, you can just vary your input parameters and see how much the output changes. So let's say R0 is 2 rather than 3. What does that mean for how many deaths there are going to be in the next month or something like that? Or you can use the mathematics of uncertainty that's taught to physicists to uncertainty propagation. But how about for the more complicated computer models? Now, once upon a time, they didn't handle uncertainty at all, really. So back, say, in the 70s and 80s, we had computer models for the weather, which, as we talked about before, divided the atmosphere up into cells and calculated what was going on. And these needed really powerful computers to get each cell pretty small, and they would typically run on a supercomputer cluster for 10 hours a day to come up with a prediction. And so people only ran one model. They'd try their absolute best guess. They'd get the best data coming in and the best models and the best predictions, and then use all their computer directions to make this one model as good as possible. But that all changed in 1987. 16th of October 1987, there was the great storm that came through England. Famously, a weather forecaster said, earlier on today, apparently a woman rang the BBC and said she heard there was a hurricane on the way. Well, if you're watching, don't worry, there isn't. That was actually misquoted, but never mind. That was what people remembered. And then 3 hours later, a massive windstorm came through with $3 million in damages, 16 million trees blown down, 22 people killed. And the next day, everyone was incredulous. If you can't forecast the worst storm in several centuries 3 hours before they happen, what are you doing? Said one news presenter to the weather forecaster. Well, what happened? What went wrong with their forecast? Well, basically, actually, nothing went wrong with their forecast. It just so happened this was a time when the atmosphere was particularly uncertain. What they've done with the benefit of hindsight, as you can see in this graph here, this is from the book The Primacy of Doubt by Tim Palmer, who did this work, is if you take all the weather data that you had a day before, and instead of running one forecast, you run hundreds of forecasts. So what you might do is, of course, you've got the weather data in particular places, might be a weather ship or a weather balloon or a satellite data, but there are many other places where you don't know what the weather is doing. And so you interpolate, and you can interpolate in different ways. So maybe it's a bit higher or a bit lower. There's uncertainty in that interpolation. So what they do here is, instead of just having their best guess at the starting conditions and then running it forward, they try a range of guesses. They say, well, it could be, we've not actually got a weather station in this particular part of the ocean. We think it's going to have a pressure between this and this, so maybe try 3 or 4 different numbers. And then you take all these different simulations, all starting with very slightly different initial conditions, and run them forward. And this is expensive. It means you might have to run 100 or 50 or 10 or whatever weather simulations rather than just one, which means you're going to have to use 10, 100 times less computing power for each of them. So each forecast is not going to be as good as if you devoted all your computer power to just one of these things. But the benefit is that you can see how uncertain it is. In this case, these graphs are showing where the wind is at a particular time, and you can see most of these graphs have not much wind, like this one, this one, this one, this one, but there are a few with really strong winds occurring in different places. This is telling us that this is a time when the weather forecast is highly uncertain. That inevitable uncertainty in the starting conditions has a huge impact on what's going to happen later on. So if you feed all these things through, you can get a graph of the probability of hurricane strength winds. And you can see that it's actually, even the highest place, it's only going to be 30% or so. But there was a 30% chance of really high winds over part of south of England and a 20% part over a larger place. I was actually asleep during the storm at my dorm room in Cambridge and remember waking up to hear the wind flapping on the flagpole and thinking, oh, it's a very windy night. 30%, that's not zero, but it's a lot more than the normal chance. So in fact what was going on here is, given what they knew ahead of time, there was a much elevated but still less than 50% chance of really strong winds. And so a good forecast will say, well, we're not certain. It's entirely possible there won't be any wind at all, but there's about a 30% chance of something pretty bad, so you park your car under cover Don't go driving, trees might be falling. But you can see this is actually quite unusual. Here is what most weather forecast ensembles look like. This is a 3-day weather forecast starting November 26, 2021, probably the day when the author was writing this book. And you can see here all the different ensemble forecasts all look much the same. This is usually the case. Most of the time, the uncertainty in working out what the weather is in all the places we haven't got weather gauges doesn't make much difference. But occasionally it makes a huge difference. And ever since then, the weather forecasters always run a whole set of models rather than one. It is a sacrifice. It means each model is going to be less accurate because there's less supercomputer power behind it. But by looking at a whole string of these models, they can get some sort of uncertainty. And they can realize that sometimes the forecast is extremely clear. It's going to be dry and sunny regardless. Sometimes it can be quite unclear. So if you hear a weather forecaster saying something like, the timing of this front is a bit uncertain, or we're not sure if an east coast low is going to form, this is what they're getting it from. They're getting it from these ensemble models, as they're called. Here's an example of tracks of 3 hurricanes using from a European forecast. This is Cyclone Seda heading towards Bangladesh. And this case, it was all the tracks pretty much went in the same direction. You know it's going to hit quite a narrow area. This is Hurricane Katrina, which is of course the one that devastated New Orleans over here. And you can see that at this point, this is a week-long forecast of where it's going to go. This was actually fairly uncertain. Most of the forecasts had it going across Florida and then turning up towards the US mainland, but it could have hit in a wide variety of areas. In fact, one model even had it missing the US at all. Over here is Hurricane Nadine, which case it was totally uncertain. It could turn left or it could turn right. So these sort of ensemble forecasts, where you take what you don't know and randomize it and then run it forward for all the different things, allows you to see how uncertain things really are.